Welcome back to a special hangover edition of the Beginner Game Programming Series. I'm Chili, and this is lesson 19. Today we're going to be talking about file access. So it's a very useful topic anyways. It's not that difficult. It's quite straightforward. So let's go ahead and fire up our old IDE and start a new project. This will be the last project we are going to be doing for console applications. I'm going to call mine Files with a Z, because I'm edgy like that. We'll get rid of the precompiled header. We'll make empty project. Ooh, I hate me some precompiled header. Okay. And as usual, we have to add a new item. Add a CPP file. And we'll call it main. Not mail, main. Yes, so what do we need to access files? Include stdio.h. Same thing we need for doing console input and output. Now, can I find my curly braces? Nope. I bet you they're right here. Fucking thing! Hate this fucking keyboard. I'm gonna have to turn on the lights again. God damn it. Okay, now, to access files, first you need to open the file. And to open a file, you need a pointer to a file object. So we'll create file pointer p file. And then we say that we initialize the value of p file to the return value of the fopen function, which surprisingly enough opens a file. And now we need two strings. First string is the name of the file. So we'll call this file, I don't know, we'll call it foo.txt. There we go. And the second string is the mode in which we will open the file. We'll just put W for now. That's write mode. Write. Alright, so now we have our file open. Now every time you open a file, or for every file that you open, when you're finished with the file, you should close the file. It's good manners. You weren't born in a barn, were you? Then close the damn file. Fclose, and you pass it the pointer to the file. And that will close your file. Now, in between your fopen and your fclose, you will hopefully have some file access function calls. Here's a good one. fprintf. It's like our old pal printf, only you pass it a pointer to a file as the first argument, and that will determine which file the data is going to be written to, or in this case the text, because fprintf outputs text. So what kind of text? I don't know. The dude abides. There we go. And so what do you think this program will do? Take a wild guess. I'm gonna build it, make sure I didn't fuck it up. I did fuck it up. Fopen, no, that's not it. Syntax error, missing semicolon. There. Alright. And we run the mother. And nothing on the console, because all our output was going to the file. So let's take a look-see at the file. This should be in Files. Files, and we have a file here, foo.txt. So yeah, if you open a file in write mode, what will happen is if the file does not exist, it will create the file for you automatically. How very thoughtful. And in our file we have the text, the dude abides. So I will count that as a success. And that is how you, oh, you cocksucker, my ID froze up again. Back. Okay, so yeah, and I mean, if you want, you can format data into your text as human readable ASCII code. For example, calculation. I'm just gonna make it all formal here. Int a is equal to 1, b is equal to 2, int c is equal to a plus b. And then here we go, calculation %sign d plus %sign d is equal to %sign d. Get a \n in there, although it's not necessary. Now we don't put it in there, it's only a file. And then we need our arguments to go in our formatter. So we'll go A, B, C. So again, make a prediction. Make a wish on a shooting star. Damn it! Now I can't find out which things are... Bleh. This one. This one. Here. I gotta stop closing this goddamn thing. Here we go. Calculation. 1 plus 2 equals 3. Brilliant. Simply brilliant. So that's works exactly the same as our old printf. Now we can also open the file for reading. That's what they are. And in that case, we can read something from our file. So let's do that. Now to read, what do you think we're going to use to read data from the file? scanf, right? There's nice symmetry there. File. Now we need to read some stuff in. We're going to read in a string. I'm interested in seeing what this will read in, because I'm not sure exactly. And we pass it a pointer to a character buffer. So we need a buffer. So we go car buffer, this one. Yeah, I got it on the first try. So we'll accept a maximum of 255 characters. We'll never need that many, but no, son of a bitch. I'm gonna figure out where all the keys are on this keyboard one of these days. I swear. Probably like the very last tutorial I ever do. Who am I kidding? I'm gonna be doing these tutorials until I die. Okay, so we'll scan in a string from our file into our buffer, and then we want to print that out. So printf, just normal printf, %s and \n and buffer. There. So let's make a prediction. What do you think will happen? Now, personally, I fucking closed that thing again. I did it again. Personally, I think it's going to read in calculation : and that's it. I think it'll stop when it hits the white space. But I could be wrong. It could read the whole line in. So it's either going to be the whole line or it's going to be calculation : Let's see what it is. And it's calculation : So there you go. So scanf with a S formatter in it will give you a string up until the first space is reached. Which is good to know, right? It's good to know these kind of behaviors. Alright, so that's how you read and write text from a file. Now, text is not the only thing that we can read and write from files. We can also read just raw binary data. Alright. Let's try that. So we're going to write some binary data to our file. How do we do that? Well, first off, when you're writing binary data, you have to make your mode, you have to put a B after it, meaning we're going to be working in binary mode. And then you go, what do? We go F write. We need some data to write. So I'm going to go int data is equal to delete. And then we go. So we need a pointer to the data. That's what that constant void pointer to string. It doesn't mean a character string. It means any kind of data. So we're going to say address of data. And then we need the size of the data. So here's a new operator for you. It's called the size of operator. And it'll give you the size of any variable or any data type. So I'm going to put data in there. And it's going to be 4, by the way, because an integer takes up 4 bytes. Size of gives you the size of data in bytes. Then what we want is we want the count. We're only going to be writing one int, so we only put 1 for the count, and then always our p file, which file to write to. Now we will compile this mother. And now we're going to run it. And I'm going to tell you right now this won't work. Can you tell me why it won't work? Let's see how on the ball you are. So I run it and press any key to continue. Let's look at our foo.txt. And it still says calculation 1 plus 2 equals 3. So obviously that did not work in our favor. Why? Because we're still opening it in write mode or read mode when we should be opening it in write mode. So that is why that didn't work. So make sure you be aware of your R's and your W's. Alright, now we'll run it, and now we will look at our file. And now we have garbage. 9 bar blankety blank. Okay, so that's not leet. But you shouldn't expect it to be leet because we're writing the data in binary. So it's going to be it's not going to correspond to ASCII codes that are readable by humans. It's not for the eyes of humans, but we can still take a peek if we want. All we need is a hex editor. Yeah, a hex editor. I got this one free on the internet. It's called Fred, and it's free, which is one of its greatest virtues, because I'm a cheapskate. So I'm going to drag my foo.txt onto my hex editor, and now we have a look at what values we have here. So this is the character values, the ASCII code values. And we see we get the 9 and then some unreadable ASCII codes. And here is the actual hex values, byte by byte. 4 bytes because it's an int. 39050000. Now, you might say, well, that's quite a bit different than 1337, isn't it? Well, no, because this is hexadecimal. It's a different representation of that number. So, to verify that we're actually writing the correct data, I'm going to specify the value of data in hexadecimal notation. So I'm going to put leet, but I'm going to put it in hexadecimal. If you put OX in front of a number, that means you're specifying the number in hexadecimal notation. Now if I write, let me just make sure I closed my text file. I did. Now I'm going to write to the file and open it up, and now it's different. Okay, should be different. We just put a different value in there. We put 1337 hexadecimal, which is different than 1337 decimal. So let's fire up Fred, and we'll take a look at our file. And here we go. 00001337, which is what we expected. It might be interesting for you to note that the number actually in the text file or in the data file, the number actually gets put in backwards order. So the highest byte goes last, right? The highest byte is 0000, and then our 13, and at the very final 37. So 37, the lowest byte goes first, then higher byte, and highest byte. So that's the ordering. And I did something there, didn't I? Control Z. I dragged this. I didn't know you could drag and drop. I didn't know you could do that. Anyways, yeah. So it goes in backwards. How about that? Pretty spiffy, eh? You want to see any changes? No. Here's another one for you. B I G B A A L B A L L S. Big balls. It gives me an error. Why is there an error? That's not cool. It's big balls. No, I don't want it. Where did I get an error here? What? Oh wait, there's no L. Yeah, okay. And there's no L in hexadecimal. I have to use ones. I forgot about that. There we go. Now we can do it. Big balls. I got carried away. Hexadecimal only goes from 0 to F. So, yeah, big balls. Let's see if that worked. And we got a bunch of weird, crazy symbols. But if we open it up in Fred, I love that name, Fred. There we go. B-I-G-B-A-L-L-S. Big balls, all backwards and stuff. Oh, it kind of screwed it up. I should put it in the other way. I'm not going to waste any more time. Let's continue on, shall we? All right. So that's how you write data to a file. And if you want to read binary data, you go RB, and we go F read, and basically all the parameters are the same thing. I'm going to initialize my data to 0, 0. No, that's not a fucking 0, is it, bro? 0, 0, 0, 0, 0, 0. There you go. Then I'm going to read in a int from the text file in binary, and then I'm going to write it out, printf, onto the screen. And if I use %d, it will write it out as a decimal number. But if I do %x \n, that's a backslash, right? Yeah, it is. Then it will write it out as a hexadecimal number. So it'll write the number out in hexadecimal notation, which is good because that's the way we defined it. So it'll make it easier for us to verify that it's actually the correct value that's being read. And there we go. Big balls. Ah, good job. Okay, so that's reading and writing data to and from a text file in text mode and binary mode. Now I'm going to just do a quick explanation of something, and then we will say farewell to the console mode for a while. Yeah, so binary mode and text mode, what is the difference? Let me count the ways. So to illustrate the difference, let's write some text in binary mode. So we'll be opening our file up in write mode, and we're going to write some text. So get rid of this, f, printf, p file, and line 1, line 2. And that's it. Very simple. No problem, right? Nothing could possibly go wrong. Fuck that. And I closed my folder again. Let's open up foo. What? Dude, okay, what? No. Dude. Did I run the program? I didn't run the program, did I? It helps if you run the program, actually. I've found. Sometimes it helps. Okay. There we go. Line 1, line 2. However, we seem to be lacking a line break between line 1 and line 2, which is very strange since I distinctly remember typing one up here. So, what the fuck, bro? What the fuck, bro? Well, let's take a look in our old trusty friend, our ever trusty friend Fred, and let's look at it. So here we go. We got line 1 here, and then we have OA, which is 10, and then we have line 2, and then we have OA again. OA, and that's it. What's the problem? Because 10, or OA, that's the ASCII code for a new line. So why aren't we getting a new line when we look at it in our text editor? Well, let's try writing the same thing out in text mode and see what happens. So we write it. We run the program this time. We open it up. And now we have two separate lines. So obviously text mode is the way to go. But why? We need to know why. We are those kind of people. We're those curious kind of people. So again, we have line 1. But now we have 0D, 0A. So we have actually two characters between our two lines here. Two characters, 2 bytes. We only inserted one here, a 0A, but we got a 0D somehow. Now it just so happens that the character for 0D is carriage return, CR, and 0A is new line or line feed, LF, CRLF. So here's a little piece of trivia for you. Windows is stupid sometimes. And by sometimes I mean lots of times. And one of those times is basically in text files, you need 2 characters to specify that you want a new line. You need a CR character and an LF. It's called a CR-LF pair, carriage return line feed. So just a normal line feed is not sufficient. That's not good enough for Windows. Geez, man, what do you take me for? So what happens is when you write a string in text mode, the writing function will transform all of your new lines into CR-LF pairs. So it looks at every single byte that you write, and as soon as it sees a new line byte, it'll say, "Oh, we need a carriage return," and it'll shove one in there before the new line. So it inserts extra characters into your bytes so that the text files have proper line breaks. Isn't that special? So, moral of the story is if you want your line breaks to look good, the easiest way to do that is to open your file in text mode. Now that's not the big deal. The big problem is what happens if we write in text mode, if we write binary data in text mode. So I'm going to go int, I'm just going to pick a totally random number here. So int data is equal to OX, we'll say FF, OA, OO, OO, OA, OA, FF. There we go. That's a 32-bit value. There we go. So, wait. Yeah, that's okay. So we're going to write this value to our text file in binary mode. I mean in text mode. Text mode. I said text mode. F write. Pointer to data. Size of data. 1 P file. And then we're going to see what we can see. Good. Good. And we open our foo text, and again we get garbage. We get le garbage. So let's open her up in Fred and see our damage. One sec. Okay, never mind. Never mind. And here we have it. Oh, whoops. Did I do something stupid here? F. Huh? Derp. I put way too many digits in here, didn't I? What was I thinking? Let's get rid of some. Okay, wait. Redo. That never happened. How many do I want? FFOA. OOOA. There we go. That is an actual 32-bit number. The other one I had there was like way more than 32 bits. That was huge. So let's try this again. Build solution, yes. Run solution, yes. Open data file, huh? The Y is on the, whatever. Whatever, bro. Whatever, bro. Let's look it up in Fred. Welcome back, Fred. We missed you. Now, look at this file. There we go. Okay, now this is looking more like the garbage that I wanted. So, we wrote an integer, which is 4 bytes. But now we have 6 bytes. So that's problem number 1. That's fucked up, bro. Now, problem number 2 is this. We got FFOA00OA. FF, okay. OA, okay. OD, what the fuck, bro? OO, okay. OA, okay. OD, I said what the fuck, bro? What the fuck are these ODs doing in our data file here? Our data file has just OD'd and it's not cool. Someone roll him over on his side, make sure he doesn't swallow his own puke. But anyways, yeah. So what happens when you write anything, any data in text mode is every time you go to write an OA, it's going to say, oh, you need an OD in there. Let me just put that in there for you. And it'll totally fuck up your data files, just like the Jesus. And that, my friends, is not good times. That's bad news bears for your data files. Because you don't want random, OD. You don't want your data files to be randomly ODing all over the place. That's not cool, bro. Somebody got to call the ambulance. So what you got to do is if you are writing if you're writing binary data, you got to write it with the B. Yo. The WB. Are you down with the WB? What else am I going to say? I kind of forgot. Oh yeah. If you really, let's say you have to mix binary data and actual human readable data in the same text file. Not recommended, but, sometimes you gats to do what you gats to do. In that case, I recommend that you do this. fprint f p file. If you're going to mix them both, you got to use binary mode because text mode will fuck up all your binary data. And then you got to do this. So let's say I want line 1. And then we go \R for carriage return \n. So we put in the carriage return and the line feed characters both in manually. Then we go line 2, R, fuck you, and there you go. And if we do this, now our text should be all good. Now it's all good, no problem. So that works fine. So you can do all your reading and writing in binary mode if you want. It's just if you are in binary mode, you have to make all your new lines into carriage return line feed pairs. That's the only difference between text mode and binary mode, except that if you're in text mode and you try to write binary, it is gonna fuck you up. And that, my friends, is the end of file access. That's all there is to know about file access forever. No, not really, but that's all you really need to know. You know what I'm saying? I could show you something, and I will show you something. So we'll go fopen. We'll go fopen. Hurry up, bro. Bro. You're cramping my style here. What the hell? Why is this so slow? Seriously, I'm gonna hit refresh here. Dude! Okay, apparently C++.com does not want me to load, so I'm gonna load the cached file. Here we go. So here's a mode. You got read, open a file for reading, file must exist, write, create an empty file for writing. So if the file exists, it is erased. Or it is, its content is erased. And if the file does not exist, it is created. Append opens an existing file, but you only write starting from the end of the file. So it keeps all the data that exists, and you start writing from the end of the file. R plus opens a file for reading and writing. W plus, reading and writing. A plus, lots of crazy crap. So there's lots of modes to open your files up for reading and writing and reading and writing and writing and reading. And you can add a B on the end, and then you're reading and writing in binary, and it's all good. What else? What else do I want to do? I want to eat some spaghetti. Wait a second. I'm all out of spaghetti. Oh well. I had water instead. Not as good. Not as good, friends. Let's now take all this file access knowledge that we have acquired and use it to do stuff. So, what I'm going to get you to do is you're going to download a version of the PooFace called PooFace EX plus alpha. It's on the download thread in the forum. So go to the forum, download this zip file, this one here, unzip it, and then you open that mother. You open it good. Boo, I burped. It tastes like spaghetti. Because I had spaghetti before. And I wanted more, but there wasn't any left, so I had water. I already told you this story, didn't I? But it was so good I had to tell you twice. Now, I'm just going to collapse this stuff because it's getting in my way. Get out of my way. Okay, so, what do I want to say? This is the PooFace game, and it's been, improved, I guess. So it has the sound, it has the scrolling. Scrolling was something that we haven't covered in the videos, but I did it for some forum members who wanted they wanted an example of how to implement scrolling in a game. So I whipped this modification up, and I posted it. And yeah, sound and scrolling and mouse access. I got mouse access in this one. But at its heart, it's still the good old PooFace. Good old PooFace, we know you well. Oh, jeez, get out of my way, bro. I'm not going to be explaining how scrolling works. We will be doing scrolling in a project very soon. Probably within, I don't know, the next 3 lessons or so. We're going to be doing a project, and it's going to include scrolling. And in that one, I will explain scrolling in detail. In this one, don't worry about it. You don't need to know. You can take a look at the source code for PooFace EX plus alpha, see how everything's done, but you don't have to know how all the details work in order to do this lesson. Because what we're doing for this one is we want to do some file access. So what can we do with file access to enhance this game? There's 2 things that I'm going to implement here in this video. The first one is high score, right? So the number of yellow balls that you acquire is equal to your score. And it would be nice if you could keep track of this history of scores in a text file somewhere. You know, to reminisce about all those amazing gameplay moments you had playing PooFace EX plus alpha. And so we're going to make a something that will create a text file and that will record the top 10 scores. It will also record the time when the scores were acquired. That's not important. That's just an extra bell and whistle. The main thing is that we record the top 10 scores. So that's mission number 1. You just got to record the top 10 scores and keep track of them between games. So every time you start the program, it'll load the top 10 if it exists. And then every time you finish a game, it will update the top 10. And I just died. Oh yeah, one other thing I did for this one is if you press enter, you can start over again, so you don't have to restart the program every time. That'll help with testing and shit. So yeah, first thing is scoreboard. Scoreboard, high score. Second thing is going to be load and save, so we'll be able to save the game and load the game, you know, for like a long PooFace session. You might have to go for dinner, stuff like that. You want to be able to resume your PooFace EX plus alpha right where you left off. So we're going to import that all-important save game function. So save game and high score. High score is first. So that's what we're going to be doing. Now, here's the thing. If you want homework, then all you got to do is stop the video right here and try to do that shit on your own. And then when you've completed the task, then you can start the video and watch to see how I did it. Or if you get super uber stuck, then you can start the video and get some hints or just get the whole answer. So yeah, don't complain that you wish I would make more homework. There's tons of homework. You just gotta stop the video and not wait for me to spoon feed you all the information. Do it yourself. And that's a good challenge for you. And if you don't feel like it, then you can just keep watching the video. You don't even have to code along with me. You can just watch. I guarantee you won't learn as much, but it's all up to you. You call the shots. It's your adventure. Now, okay, that's good. Never mind. So, if you're gonna do this on your own, stop the video now. Since you haven't, since you're still watching, either you've completed it now or you just decided you're gonna be a lazy bastard, and that's cool. That's cool with me. I'm down with that. So let's get some high score action going. First thing we're gonna do is we're gonna create a structure to hold the high score. Struct high score. Fucking guy. There we go. So the first thing we're gonna do is we're gonna have int score. Yeah. And the second thing is character time. I'm gonna make an array of I don't know, 20 characters. Will that be enough? That should be enough. That'll be plenty. That will be way too many. Alright. I think I'm starting to figure out where all the buttons are on my keyboard. Okay, so high score entry will consist of the score itself and the time when the score was attained. And that's a high score entry for you. Now, high score. I'm hungry. Scores. End scores. We'll make this parameter adjustable. Trying to cut back on the number of magic numbers in the source code. And scores is 10. All right. Now we have an array of high scores. Now. So the first thing we're going to do is we're going to make a definition. We're going to define that a negative score, because it's impossible to get a negative score in the game, right? So we're going to define a negative score to mean that score entry is empty. It's not valid. Because when you first start the game with no high scores, you're not going to have 10 scores to fill the scoreboard. So the scoreboard is going to be completely empty. So you need some way to specify that the scoreboard is empty. And we're going to choose negative score, meaning that entry is invalid or empty. So, void clear score. Clear scoreboard. Clear scoreboard. There we go. And here, scroll down. Clear scoreboard. Game. And There we go. Fuck. Yes. Okay, so for int index equal to 0, index less than n scores index plus plus. Nope. Yep. And scores at index, go to hell, is equal to scores at index dot score, haha, equal to -1. There. That will clear the scoreboard. First function complete. Now the second and a very important function is the one that inserts scores into the scoreboard. Now this is tricky because you can't just put the score at the end of the scoreboard, the first empty spot, because we want our scores to be in order from highest score to lowest score. So let's make a scoreboard here. We're gonna make just a simple scoreboard with 4 entries in it. 5 entries. I lied. Oh, my tablet ain't working. One sec. Alright, crisis averted. Here we go. Let's make a scoreboard. 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 Yeah. Yeah, bro. We wanted 5, right? 1, 2. Okay, who told you to put that fucking line there, bro? 2, 3, 4, 5. 1, 2, 3, 4, 5. Damn it. Damn it. Damn. Damn. Just damn. That's the only word I have to explain how I'm feeling right now. I'm not very eloquent, as you may have gathered over the course of these videos. Okay, there we go. Here's our scoreboard. So let's make some scores, yeah? I'm gonna make 5 scores. First score, 35. That is a good score. For Pooh Face, geez, that's like fucking man. That's fucking man, all dang old 35. Alright. 18. 11. 7. Okay, so here's our scores. So, let's say, to begin with, these are all empty, so they all have -1 in their score value. And then, let's say the player plays a game, and then their first outing, they score 11. So we go, first thing we do is we start at the top of the array, and we look for the first empty. We look at the first entry. We say the first one is empty, so we just put 11 in here. All done, finished, good to go. Now the player plays another one, and they get a 7. So we say, okay, 7, that's our score. We look at the first entry, it's 11. Is 7 greater than 11? No. So we look at the next entry, it's empty. So we put a 7 in here. So far so good. We're still in order. 11, 7. Highest to lowest. Next time the player plays, they get 22. Not a bad score at all, if I do say so myself. So they look at the first entry, and they say 22. Is 22 greater than 11? Yes, it is. Okay. So 22 has to go in here. But we don't want to just write over 11. We don't want to say, 11, you're dead now. Go away. You suck. No, we want 11 to go down here, and we want 7 to go down here. So what we gats to do is we gats to, first of all, go to number 7, move it down here. Then we got to move 11 here. And then we can move 22 into here. That's how that works. And the same thing if we were to do 18, we'd look at 22. Is it 18 greater than 22? No. Is 18 greater than 11? Yes. So we have to move 7 and 11, and then we can put 18 in here. So we got to play a little bit of shuffling and a little bit of musical chairs here in order to insert values in their correct position in the array. So that is the challenge. Where's my thing? Here it is. So let's make it a reality here. Void insert score. Fucking guy. Score. With an E, bro. With an E. What do we got? High score. So we pass it a high score. And we don't do that because that would be stupid. Let's copy this. There's my C. And we'll go down here. Blah blah blah. Zip zap zoobity bop. There. Oh, I got it on the first try. Damn, I'm good. Alright, so first thing we do when we're going to insert a score is we've got to run down the array, and we want to find the place where we want to insert our score. So we'll go int index. We'll declare our index outside of the for loop because we want to use it after the for loop. We go index is equal to 0 as long as index is less than end score, right? Because if we go past the end of our array, that means we couldn't find any spot to insert it, which means it was a really shitty score, and you should be ashamed, and your mother should be ashamed. So that's one what do you call it? One case where we want to leave our loop. So as long as index is less than end score, and as long as second case is scores greater than, let's put it back here. Yeah. As long as scores at index greater than, scores at index dot score is greater than score dot score. Score dot score. That's kind of unfortunate, but whatever. Fuck it. Fuck it, bro. Just fuck it. Okay. So the first test here is to make sure we're still within our array, right? If we exceed the last entry of our array, then that means that we couldn't find any place to put the score. It was a really bad score. And the second case is we want to make sure that we want to keep searching as long as the score in the scoreboard no, that's fine. As long as the score in the scoreboard is greater than our current score. Because if the score in the scoreboard is greater than or equal to, if the score is less than our current score, then that means that our current score should go there, right? For example, if we're inserting 18, 11 is less than 18, so that means that 18 should be going in 11's spot, and 11 should go down here, and 7 should go down here. So that is those two, whatever you call them. Whatever, fuck it. So now we have the position where we want to put our score. Now what we have to do is, once we have our position, we've got to shuffle. So, for example, 18. Where's 18? I think this one's 18, right? Or maybe it's this one. This one, yeah. So we know 18 has to go here. So what we have to do is we have to go from the bottom entry, which is a 7, and we have to shuffle it down. And then we have to go to the next entry and shuffle it down. And then we can move our 18 into position. So we have to find the bottom of the array. The last entry in the array. We don't have to find the last entry, but see, now I'm thinking. Now I'm thinking hard. Yeah, I'm gonna do it. I'm gonna do it. What I'm thinking of doing here is, instead of finding the last entry in the array, let me just back out of this. Instead of finding the last entry, which is the 7, and then moving it, just start at the start here. Move this one down, then move this one down, then move this one down. So even if there's nothing in this position, move it anyways, because it makes our life easier. And who cares? That's just it's just a couple of moves. It's not going to be that expensive. So it's not the most efficient solution, but it makes my life easier. So we start at the second last entry. 4. Swap index, shuffle index. Shuffle index is equal to n score minus 2. Minus 1 would be the final entry. Minus 2 is the penultimate entry. There's some vocabulary for you. Penultimate. Or wait. Damn it. Penultimate would be like number 2. It's the opposite of penultimate. Whatever. Fuck it. It's the second last one. And as long as shuffle index is greater than or equal to index, which is the index of the place we want to push. Shuffle index minus. Yeah, because we want to move up the scoreboard while we're shuffling. Oh, 5th time's a charm. Yeah. Okay. And how do we shuffle? Well, sir. We go high score temp is equal to scores at no, we don't need to do that. We don't need a temp for this one. Fuck that temp, man. What we do is we go scores at shuffle index plus 1. The one below the curtain shuffle index is equal to bro. Equal. There you go. And you can get it. Is equal to scores at shuffle index. Now, I am a little rusty because I don't use structures that often, actually. But I'm not sure if this will actually copy our strings. Because remember, in here, we have character time 20. I don't know if that's going to do a deep copy of the whole string here. It should, because it's not a pointer. So we'll see. If this doesn't work, then we'll just have to do it manually. So this will copy all this shit down, right? So this will copy, for example, we start, shuffle index will be the second last one, and we copy it to the second last one plus 1. Then we do minus minus, and then we copy it to the current shuffle index plus 1. And then we do minus minus. And then we're at our position right now. We should start here. This is where we start. Right. We start here, and then we start here, and we copy this one to here. No effect. Then we go minus minus, then we copy this one here. Minus minus, wait, and then we copy this one here. Then we go minus minus, and then we exit the loop, and then we can copy this one into its original target index. Woo! Yeah. Okay, so we do this. Then we do scores at index is equal to score. Yeah. And then we're done. Except, my friends, in the case where index actually exceeded end score. So, if index is less than n score, then we insert it into our array. But if it's not less than n score, then we just do nothing, because it was just a really shitty score, and we should just do nothing. Shitty score, go home. Alright, so that should be it. That's very simple. So it has a little bit of waste. There's a lot of unnecessary copying in an empty array, but as soon as the scoreboard gets filled, then it won't matter, because you'll have to copy them all anyways. Alright, so that's our insert score function. How exciting. How very, very exciting. Let's make a new one. What should we do? What should we do? Last one we're going to make for our first little thing before we test is we're going to do void save score. And that'll just output it to a file. Game. Getting tired. Did I mention I'm hungover? Damn it. My brain is not in any shape to be doing this. Save score. There we go. Yeah, we're gonna save our score. How are we gonna do that? That should be simple, right? We're gonna do it in text mode. So we're gonna go F open. Do I have stdlib in here? Yeah, I do for some reason. I don't even know why I put that in there. Whatever. Whatevs. F open. highscore.txt. And the mode is writing. Wait. Yes, writing. Now we go for int index equal to 0 as long as index is less than n score, and as long as scores at index dot score is greater than or equal to 0. Greater than or equal to 0. Index plus plus. There. So for every score, we're going to output the score. How do you do that? We will printf. Ah, well, that would be a problem. That would be a problem, wouldn't it, Mr. Fancy Pants? File pointer to p file. We need our file pointer. P file. Okay, how do we want to output this? We could put score first and then time. We could put index score time. Yeah, I want to put index, so we'll put %D for the index, then a dot, then a \T for tab, then we put the score, %D again, then we put tab, double tab that mother, and then %S for the time, and then \N for new line. So that will be our high score line there. Now, we want index, and then we want scores at index.score. That's the actual score. And then we want scores at index.time. Scores, I said. You heard me, I said scores. Alright, and that is all we're going to do for now. And then we'll go close file. So there we'll have our save score. And it will be good. Okay. Now, I think I need one. Actually, I need maybe one more function here. We're going to call it getScore. Void, no, not void. High score getScore. High score get score. High score get score. So this one will just generate a high score object or structure, whatever you want to call it, based on the current score in the game. So here's the tricky part. We'll create a high score. High score HS. Called score. Score dot score is equal to, what did I call that thing in here? N goal. N goal means the number of goals that we have actually acquired or reached. N goal. That's very simple. This one is not so simple. Score dot time. This one is not simple at all. Alright, so let me think here. Oh, N scores. Time. Time buffer length is 20. Time bufflin. And we'll get rid of that magic number there, because I don't like it. I don't like it. No siree. So there's a function in time.h that will let me output the time in a human readable text format. formatting of my choosing. Let's see if this website is working yet. CTime. Yeah, it's working now. So the function is convert TM structure to string. Convert time T value to string. This is the one. CTime. Ah, that's way too long. I don't like it. I don't like it one bit. Now here's one, ask time. Nope, that's not one I like either. There's like one that lets you format the time. Convert structure to string. Format time to string. Here we go. String format time. Okay, here we go. So we need a constant structure TM pointer to time pointer. We need a format string. We need a pointer to the buffer and a max size. Now, here we can use these formatters to specify how we're going to give the day and the time. So what I'm thinking is we do it year, month, day with slashes, and then we do another slash, and then we do hour, colon, minute, colon, second. So let's do that. That should be less than 20, I think. Oh, hour, minute, second is just X. Beautiful. Oh, sweet. And date is just X. 08/23/01. Okay, good. Good. So, just X, just small x, and then big X with a slash in between them. I can do that. That's what I can do. I can't remember. String format time. Yes. Okay. Score dot time. What was it called again? Time buff len. Yeah. Format string is gonna be was that big X small x or small x big? I think it was big X small x. Big X slash small x. Yeah. We need a time structure. All right, back to the drawing board. How's it work? How's this work? Where am I? Who are you? Make time. Convert TM structure to time T. Get current time. I don't convert time T. Local time. No? Time? How do I get a TM structure? Dude, struct TM. How do I get that? You suck, bro. Bro, you suck. I'm guessing local time is the only way to get a TM structure. Uses time to fill a TM structure. Okay. Okay. I think I'm starting to understand how to do this. Convert TM structure. Make time, convert TM structure to time T, difference between two times. Yeah. So I have to use local time. Gotcha. I understand now. What I gotta do is Fuck, I forgot the name of the function. Local time. Local time. Time t pointed time. Time underscore t. Time is equal to time. Get time. Time. It's just time, bro. It's just time. Naruhodo. So time t current time is equal to time null there. So we get the current time, and then we convert that into a local time structure. And then we use that to get a string. Oh man, this is complicated, bro. Who invented this library? I want to kick him in the balls. Local time. String format time. Oh wait, I got that already. That's what this is. Good. I knew that. Sure. So, if I do this, then I can return score. This should work. Maybe. Doubtful. It's doubtful, friends. It is very doubtful. Let's build it anyways. Yeah, that didn't work. That did not work. End score is unidentified. What? Dude, I made it in here. I totally made that one. And scores. Fucker. You are a bag of dicks. Find it and replace with. And score. Wait a minute. I'm doing something stupid. Why don't I just do this? And then do this. That seems like a much more logical. Yeah, that didn't work. Shuffle index undeclared identifier. What are you talking about? I declared it. I did it right here. You just didn't look close enough, stupid compiler. It's all your fault. End scores undeclared. I'm just using them all over the place here. I like to switch it up a little bit, you know? Keep the compiler on its toes. What? Okay, that doesn't matter. You. What's your problem? What is your problem? Missing blah before blah. Missing blah blah blah. This is difficult. High score? Game. Aha! It doesn't know what a high score is because high score is stuck inside of the game objects. Or the game thing. The game thingamajig. I had to qualify it there. Oh, succeeded! Yes, I'm a winner. Yeah, I'll consider using fOpenS. And then I will not use it. Because I'm lazy. Okay, so now I should be able to get score, save score, insert score, and clear scoreboard. So let's use these functions in order to begin to get this working here. So reset game and reset scoreboard. Wait, clear scoreboard. Clear scoreboard. So this is what we do when our game object is first created, right? We clear our scoreboard. Now, when we get to a game over, this is actually, I should write a game over function, but I'm not going to. I should though. We want to go to update poo. Where's update poo? Update face, update camera, update poo. So the game is over when we collide with the poo. So then we go game is over equal to true. And we have to insert a score. We'll do that first. So, first thing we do is we get score. I can do that. Doing that is what I can do. So, high score is equal to get score. Good. Then we insert score. Fuck, do it. Bro, I can do this in one line. I'm gonna one line this mother. Insert score, get score. There. Cut out the middleman. So we insert a score. Then we say the game is over. Then we play our fart noise. Good job, bro. Now the last piece of the puzzle. Is save score. We want to do that when our program is being closed. How do we know our program is being closed? How do we know our program is being closed? Well, the game object has a constructor for when it's being created. It also can have a destructor for when it's being destroyed. This is C++ object-oriented stuff that I will be getting into later on in the next series, which is coming up very soon, by the way. To declare a destructor, you go tilde and then the name of the object. That means it's a destructor. And destructors, they always take no arguments. Just you have to put a tilde in front of it to show that it is the destructor. Now that we have a destructor declared, we can define its behavior. So we go game, and then we go tilde game. And in here, we want to where is it? I'm going to save score. I don't remember the name of the function. Save scores. Damn it. Save score. Good enough. Should actually be save scoreboard. Control C. Where's my escape scoreboard? Where's my skip scoreboard? I'm losing my mind here if you haven't caught on. Get score, save score. There we go. All right. Here we go. Build it. It's gonna work. Didn't work. Fuck. Insert scoreboard, not a member of game. What? That's because it's insert bro, I did the wrong one. Save score, not. It's supposed to be save scoreboard, not insert scoreboard. Okay, here we go. Now it works. Good. Now let's see how bad it crashes. No crash so far. It worked. Go. Oh, jeez. Sweet. Let's go. Let's keep it going. Sweet. Oh, that was close. That was fucking close, bro. You were this close to dying. Poo face, man. Gotta see how many I can get. Never mind. I did that on purpose. I swear it. Now, if I close this, didn't crash, but it should have written to a file. Cross your fingers, bros. We got highscore.txt. 0, 6. Okay. Not bad, not bad, not bad. The tab is a pretty big tab, but whatever. Okay, first things first. So, save scoreboard. One tab is fine. What we want to do here is we want to do index plus 1. Index plus 1. Because we want our first score to be score number 1, second score to be score number 2, so on and so forth. Score 0 just doesn't have the same ring. Second thing that we want to do, we could make it prettier. I could like make borders and shit and make it all like pretty and shit. But you know what? Fuck that. Because I don't want to do it and I don't want to waste time on this video doing that. Let's play the game instead. Where's my... Dude. Where's my car? Oh, wait a minute. Go. There. Okay. Get some. I'm gonna get some. Get some. There. 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 No. It's gonna be up here. I know it. There it is. Whoa, that was freaking close, bro. Bro, that was super bro. Okay, that's first one. Now let's get another one. This one's gonna suck. Get 2. Oh, he died. Okay, that one was 2. Let's get 1, 2, 3, 4. Bah, we'll get 4. Let's get 1 this time. We'll just get 1. Give me 1. There we go. Good. Let's get 0 this time. Yeah. Okay, let's get a whole shit ton. 1, 2. You guys remembering all these numbers? Because I'm not. 3. Fuck. Okay, I got 2. Whatever. Okay, let's take a look at the file. We'll see what we got. Alright, so here we go. Here's our high scores. So high score number, the first high score was 6. And that was the very first one that we did. And then we got 4, and that was, what, the third one we did, maybe? Judging from the times. No, the second one we did, we got 2. And the third one we did, we got 4. And then the fourth one we did, we got 2. And then the fifth one we did, we got 1. And then the sixth one we did, we got 0. So, that is how that works. And it works quite well, in my opinionation. Now we have to implement the final part, which is load score. We want to be able to load the high scoreboard from the previous session, so we can continue it in the next session. So we go game.cpp. Void load score. I'm not even gonna bother making like the file name for the score. I'll just put it as a magic number. Magic constants. Load score. Game. Wait, void game load score. Alright, now here's the thing. We want to load. I want to ignore some characters and then we want to load. How to do this? Because we don't want to. The thing is that the text file here. files. Text file. It has these numbers here, and they're not part of our scoreboard. They're just added for, I don't know, for whatever. So what we want to do is we want to ignore these ones. We just want to load this number and this string. How do we do that? How do we do that? There's a couple ways we can do it. First thing I'm going to do is I'm going to get rid of this extra tab here. That's too much tabbing. That's too tabby. Next thing I'm going to do is, I think what we could do is we could seek forward. We'll use fseek. How's that work again? stdio. I'm going to go f seek. Where is it? fseek. So we need origin, seek current. Interesting. Interesting. So here's what we're going to do. Got our thing here. We got our high score. We want to, first thing we want to do is we want to seek forward. We'll seek forward 3 characters. So that's 1, 2, 3. Then we'll read in this number. Then we'll read in this string. Then we'll seek forward 3 characters. The new line, this one and this one. And then we'll read in this number here. It'll ignore the tab. And then we'll read in this one here. It'll ignore the tab. Yeah, so first thing, we just gotta seek forward 3, then read, read, seek forward 3, read, read. It'll work. It'll work fine. Damn. So first thing we do, we want to seek, then we want to read, then we want to increment. Yeah. Yeah, let's do that. Okay. And my ID froze up. Thanks a lot, dickface. Alright. F, open. Okay. What was the name of our file again? I think it was highscore.txt. And the mode was reading. Well, it's going to be reading this time. What else are we going to do here? Partner. Now, for index equal to 0, as long as fseek. Aha! I always forget this. File p file is equal to f open. There we go. Now I want to seek forward 3 characters. So p file 3, and the origin is seek underscore cur. These are just like kind of enumerations for stating what kind of a seek you want to do. We want to seek from the current position. So while this fseek, now the return value of fseek, Check end of file indicator. Alright, I don't think we need to do that. fseek will fail if we hit the end of the file. I think. I'm not sure. I'm not sure about this one, people. But if we hit the end of the file, fseek should return non-zero. Which means 0. So while fseek is 0, while not fseek, meaning while fseek is 0, we want to keep seeking. Yeah. And while index is less than n score, because we don't want to exceed the array, the end of our array. Index plus plus. So in here, the test, or the sentry value for our loop, our for loop here, is actually the part that skips those unnecessary characters. Now, here's what we're going to do. Scores at index dot score is not equal to. We want to scan f %d address of this stuff. So scan in our score. We could do 2 for 1. Space, that'll ignore all white space. String, scan in a string. Address of scores index dot time. There we go. Alright, and then here we go, f close p file. So this should read in our file, but I have very little confidence that it will work the way I want it to, because I'm not exactly sure about the behavior of this one and some other stuff. And yeah, but it might work. It could work. Stranger things have happened. So we want to load score in our constructor here. Clear scoreboard, load score. Yeah. What'll happen is if the high score does not exist, this will fail. This will fail. I think this will fail. I'm not sure. What does fopen return if the thing fails? Does it return null? Null pointer to a file? If that's the case, then no, because if we pass a null pointer to fseek will just fail. And when it fails, this loop will exit without writing anything, and then we'll close on a null pointer. That'll just fail too. So it's all fine. It's all good. It'll work. In case the file does not exist, we just get an empty array, which is what we had before when we started. Just an empty array of scores to be filled up. Okay, so why are you failing? Warning, warning, warning. Error. Right. So time is already a pointer, right? It's an array, right? And as you know, an array without the index after it is just a pointer to the beginning of that array. So we don't have to use the address of operator in front of this one, because that's already an array. It's already a pointer. Arrays and pointers are like this. Remember, I told you they're like this. What's your fucking problem, bro? Cannot convert parameter 1 from cos. Right, I I need the file. P file. There. Okay, now can I frickin' have my executable? Thank you very much. Now let's crash. We didn't crash. Let's kill our poo face. No, we don't want to kill our poo face yet. Yeah, let's kill our poo face and see if we got our high scores. Good. Now let's look at our high score thing. Files. We should have another 0 in there now. No. We have a 6 in there. So we managed to load the first one? Yeah, we managed to load the first high score, and then our loading function crapped out. And then we added one from our current. Right, so we're not loading everyone in the score thing, we're only loading the first one. That's a problem, but it means we're on the right track. I need, what do I need here? I need to be debugging this here. That's what I need. All I need is a miracle. All I need is you, Mr. Debugger. Okay, so we open highscore.txt. P file. Okay, so P file, bad pointer, buff size, temp file name, bad pointer. I don't know if that doesn't sound good, actually. Is that good? It sounds bad. I don't know, it sounds kind of bad to me. Can I seek? Yeah, I seek and I scan. I read in stuff. Index is equal to 0. We get index plus plus. We seek current. We scan. And it did not work at all. Score is equal to -1. Where is it? Score is at index. What is index? Index is 1. P file. Where? Why didn't that work at all? Whoa. Whoa, bro. Score is equal to 19. No, it ate the wrong. Wait, I got an idea. I'm seeking 3, right? I'm seeking 3 ahead. Think about it. But look at this here. There's actually 2 characters at the end here. There's a carriage return and a line feed. Then there's 2 characters here. So that's 4 characters. I should be seeking 4. But if I seek 4 here, then I go the wrong way. So, for the very start of the file, I only want to seek 3 characters. And then afterwards, I want to seek 1, 2, 3, 4, 5. At the end of... Okay, I got it. I got it, bro. Here's what I want to do. First, I want to stop this. Then what I'm going to do is... Alright, here's what I'm going to do. I'm going to make this a do loop. This time for sure. This time I'm definitely making it a do loop. Do. So first thing we're going to do is we want to just seek to get rid of those first three characters. So we do f seek and p file 3 seek current. So we seek forward 3. Now we enter the loop, and we want to scan something in. Then we want to increment the index. And we do this while, and here is where we do our other seek. And make sure we're not, just in case, make sure we don't go outside of our array. Now here we want to seek 5, right? CLRF, then the number. Wait a minute. Okay, 5 is fine. That's fine. That's okay. It's good. We'll seek 5 characters ahead. Yeah, that'll work. That'll work just fine. We do int index equal to 0. Here we initialize that. This should work. Okay, we got success. Now we'll just start off with a clean high score. So let's do it. Let's get some high scores. Debug assertion failed. What? fseek. Streams not equal to null. Ah. Abort. Abort. Okay. So apparently, if we try to seek and the file does not exist, we get an exception in debug mode. That's annoying. So let's do this. If p file I don't know what any of those mean. Damn it. How do I tell if fopen succeeded or not? This is what I want to know. Error. Error indicator associated with the file was set. If the error indicator was set, non-zero. Otherwise, it returns a 0. So 0 means good, non-zero means bad. So if not f error, meaning if bad. Wait, now I'm getting confused. 0 means good. Right. So if good, then do this stuff. Otherwise, we had an error. In which case, we don't want to try to do anything, we just forget about it. Error equals we couldn't open the damn file. And so we should just forget about it. What's your freaking problem? Oh, right. We need to tell it which file pointer we're talking about here. P file. There. How do you like them apples, bitch? Debug assertion f error. Okay. Here's how it works. Abort. Here's how this works. If fopen fails, p file is just null. So, if p file, meaning if p file is not null, if p file has some value, then we do this stuff. Otherwise, we just forget about it. Now, will you fucking let me run program? Yes, you will. Thank you very much. Alright. We got 1. Geez, we gotta get a couple. 2, 3. Can we get more? 3. Fair enough. Let's try again. 1, 2, 3, 4, 5, 6. There. Let's get one more. 1, 1, 2. There. Okay, now we'll quit. So we've gotten a decent scoreboard built up here. There it is. 6, 3, 2, 1. There. Now we're going to add to it. We're going to try to add to it. Let's run the game again. Alright, so far so good. 2. There's another 2er. 1. Let's try to get 5. We didn't have a 5 yet. 1, 2. Jeez, you're making it difficult for me. 3, 4. One more. 5, 6. Damn it. Whatever. Whatever, bro. I did it. I did it. Did it. See. Yes! It's working like a fucking charm, isn't it? That does work perfectly, doesn't it? Yeah. Now we're just gonna make sure that it doesn't do stupid things when we get to a full high score table. Because that's another risk. It could start being like stupid and stupid. You are stupid. Yes. That's 2. That's 3, 4. That's 5. Yeah. Yeah. That's enough. Okay, let's see. What's our high score text look like now? 6, 6, 3, 2, 2, 2, 2, 1, 1, 1. Good. And now the zeros, they didn't make it onto the scoreboard. They got all kicked off. So that is exactly what should be happening. So I think high score is basically done. I mean, we could make it prettier. We could, you know, put a border around it like this and go star high scoreboard. Zzz. And then we could do, I don't know, do something like, here we could do score, and then here we could put here time. Then we go like this, and we put a thing here, and tab that, put a thing, no, yeah, no. Let me waste more time. I'm wasting time. Don't prevent me from wasting my time. Do something like that. We could put like a border around it and shit, and it'd be all pretty and stuff, but fuck that. I'm not gonna do that. You get the idea. Don't save that garbage. And obviously if the scoreboard gets all fucked up, then it's gonna fuck up our game when we load. So we would want to write code in here, so in case the scoreboard is corrupted, we just erase it and start new. But I'm not going to do that either, because I'm lazy. You get the idea. The idea is that we can read and write text to a file. Now, the second part of this... Fuck, this is getting to be a long lesson, longer than I expected. The second thing is I want to be able to load and save game data, game state. So to do that, we have to look... That's actually maybe easier than what I was doing here, if you can believe it. We have to look at all of the state variables and... let me think here. So in order to load and save the game, we have to save basically all these variables. And load them. So void save game. We're not going to make like multiple save states or whatever. Just one save state you get. It's all you get. And you should be thankful that you get even that. Load game. Now, the game state will be independent from high score here. We don't have to save game is over because you can't save or load in the game is over state. That'll be disabled. So we just don't have to save these ones and this one. Yeah. So let's do it. I'm just gonna copy this so I can remember it. Copy. I'm a copy pappy. I'm losing my mind again. Chili's losing his mind. I have to go play tennis now. So I'll be back in a few... Well, for you, it'll just be a couple seconds. See you then. Alright, where the hell were we? I cannot remember for the life of me. I got a void here. Let's see if I can paste something. Control V. Shit. That didn't work. Okay, what was I doing? Okay. I'm gonna write these functions. This is a problem. I can really not remember what I was planning on doing. I have an idea. We were gonna do what was it? Yeah, game there. Yeah, we're gonna do C, Control V. Saving the state of the game in progress. So that would entail what? First, let's copy basically just all these variables here. All these ones. I'm just gonna paste them in here just to give myself something to remind me. I'm gonna get rid of this because it's in my way. And now, okay, so saving a game, we got to open a file. File pointer to P file. F open. File name is save dot I don't know DAT. Good old DAT file. We want to open it for writing and binary mode. Don't forget that B. That will cause a plethora of headaches, a myriad of stuff that you don't want. F close. P file. Okay, now in here, basically we're just going to write all of these variables in there. So, yeah, let's get on it. Let me think here. F write, fright, npoo, address of, npoo. These are all ints, so I'm just gonna go size of int. That'll make my life easier. 1 P file. Alright, now we get to the copy and paste magic. Copy pay. 1, 2, 3, 4, 5, 6, 7, 8. That's all we need. Good. Now I can just go like this. Copy, paste. Copy, paste. Copy, paste. Copy, paste. Copy, paste. This is riveting, isn't it? There. Okay. Now, that's that. So we've written all of those ones. We don't have to write this. Because that is not... It's always going to be false when we load a game. What else? Now we got to save all the poos. So for int index is equal to 0 as long as index is less than n. Fuck you, bro. N boo index plus plus. There. Now, this one's easier. F right. Let's do the same thing here. Address of poo at index. No. Stop writing in Japanese. Size of poo. What is size of poo? Don't tell me that. Nah, don't tell me that. Whatever. And what else? One. Oh, fuck, bro. I don't have to do this. Dude, what am I doing? I'm doing it the stupid way. We don't need no goddamn loop for this. F right has got it on. So all I gotta do is give it the address of my array of poos, which is just the array name by itself. Then the size of one poo, and then however many poos I want to copy. I want to copy n poos, and then I just go p file. And it'll copy all my poos in the whole array right into the file. How sweet is that? I almost did something incredibly redundant. Okay, load game is going to be the same thing, but different, kinda. Let's just copy this. Down here I'm going to put, just in case, what is it? What do you want from me, game? Okay, I'm thinking here. Can you smell the smoke? Fuck. Game over. Game is over. Is equal to false. In case we load our game during game is over equal to true, we want to set it to false. All right. Because you can't save game. I'm gonna make it so you can't save game when the game is false and game over is true. Therefore, when you load the game, game over must by necessity be false. Yeah. All right. Now we're gonna take these f writes and we're gonna say f read and copy paste 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 paste, and that's that. That's how you do that. Probably we should change this one. Now the problem is if f open does not exist, then we're gonna get that annoying shit again. So if p file, there we go. If we actually succeeded in opening the file, then do this stuff. Otherwise, just do nothing. Beautiful. Let's build the bug. Oh, it actually worked the first time. That's ominous. Ominous. Yeah. So now I gotta figure out where I'm gonna save and load. How am I gonna pull this shit off? Update face, update poo, update camera. So, here's the saving. If this is annoying. I don't want to like Here's the thing. If I do something like if keyboard dot I'm gonna do, because we're using the mouse for movement, we have all the direction keys freed up, so I'm gonna go save is down. So if down is pressed, save game. So So if we save the game, we're not updating the frame. We're not going to do both. So that's almost like a pause game button then if we do it like that. The problem I'm thinking of is if you hold down the down is pressed button, it will save the game once every frame, and that just seems stupid. You shouldn't be able to save the game like every freaking single frame, right? Because that's just retarded. But I don't really have a good way to ensure that it only saves once for every single press, unless I do that thing I did with the tic-tac-toe game. That seems like a lot of work. I could do mouse button clicking. Seems like a stupid way to do that. There's got to be something I can do without having to think or work. We'll think about it later. For now, we'll just leave it like this. And we'll say that we're not satisfied with that solution. If down is pressed, save game. Here, if kbd.up is pressed, load game. Else if. So if we press up, we load game. Otherwise, if the game is not over, then we do the updating, and we also check to see if we have to save. And if the game is over, then we check to see if enter is pressed, and then we can reset the game. That seems pretty good. It's not the best, but it'll do. Alright, so up is loading, down is saving. Fuck you, man. Why'd that sound come out? Oh, I think I started right where the target was. Free target! Okay, so up is loading. If I press up, it pauses the game. Right. It's trying to load, but there's no file to load. Haha! 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 What else can I do? I can save the game. I just saved the game. I saved the game, bro. Let me turn the game off. Fuck it. I'm gonna try again. Now let's load the game. It worked. I loaded it. I loaded it. I did it. I did it. I did it. Did it. Damn it. Save states. Whee! Okay, let's get this. Let's see how many of these poos we can get. Come on, bro. Give me some. I mean, not poos. I mean, what are those yellow things anyways? I'm gonna call them pee stains. I should have fucking saved it when I got one. Save state. Where am I? Where am I? Serve. Interesting. Game keeps going. Normal speed, even if I'm saving it every single frame. Save. Ha ha ha. Get some more. Oh, load state. Heh. Heh. Save. Bro, you cannot beat my save scumming. Come at me, poos. Come at me, bro. Yeah. Come on, come on, come on. Where's my pee stain? Come on. Save state. Should be. It seems like. I think I might have maxed out the number of poos. Is that possible? Load state. There it is. Damn it! Load. It's up here. Ha! Save. I think I might have maxed out the poos. Save. Should add more poos. Let's end. Alright, game over. Okay, so. Just for shits and giggles, let's look at our files now. That's not what I was looking for. You didn't see that. Foo.txt. That's not what I'm looking for either. Fuck! Where's my fucking files, bro? Here we go. Pooface EX plus alpha. That's the name. Epic name. Highscore.txt. So here's our high scores. 13. So that was the best we did, 13. Which meant that there was a maximum of 39 poo. I think I cap it at 25 though, so that's why we weren't getting any more poo. But I got 13 pee stains. Yeah. And what else? Save.dat. Let's open that file up. Select from a list of programs. We'll open up in WordPad. So here's our data file. I understand you perfectly. Not. So we'll open up our hex editor. We'll practice some safe hex. So here's our binary file. I don't know what these numbers are supposed to be, bro. These are my ints, right? So this is the n poo, right? Look, 19. Really? 19. So hexadecimal 19, which is 16 plus 9 is 25. Yeah, 25 poo. Like I said, the maximum we can get. So 25 poo, and here is, I don't know, probably the number of goals that we got. D is 11, which makes sense because our high score was it 13? 11, A, B, C, D, E, F. 13. Yeah, D is 13. That's what I said. I said 13. Or is it 12? D, E, F. 12. Fuck it. I don't know, man. I don't know, bro. I don't know what these numbers mean either. What the hell are these? This is probably the, let me look at the thing here. This is faster. Alright, here we go. First one is poo, then goal, then face X. Oh, so here's the coordinates of our face. Face X, face Y. And then here's the coordinates of our camera. Right-ho. Camera X, camera Y. And then here is the start of our poo. Yeah? Alrighty then. So... whatever. Whatevs, bro. This is what our save file looks like. And as you can tell from the game, it works fine. I can load up my game right from here. Bam! Look at me. I'm playing from my save game. And now I'm gonna quit. And I died. Alright, so that's saving and loading. It was quite simple. Much easier than, managing a scoreboard and stuff like that. So, yeah, that's a lot of file stuff for you. A lot of stuff to chew on. I hope the more adventurous of you tried it on your own instead of just, being spoon-fed. Like a bunch of retards. No, I'm joking. Ha ha ha. Not right. I'm joking, but I'm not. Anyways, yeah, that's file access. I don't know what to say. That it is what it is, right? I don't think it's that hard, really. I hope you agree with me. And now, because we know how to access files, we can load image files, which is what we're going to be doing in the next lesson. So next lesson, we're going to be loading sprites from bitmap files and then drawing them on the screen, which a bunch of people have been pestering me about for I don't know, for months now. When are we going to get to do sprites, bro? Ugh. So we'll finally get to do sprites. Whoopity-doo. And yep, that's what we're doing next lesson. So,